So today I will be presenting my project titled Fake News Detection Using NLP and Deep Learning, Calibrated Linear SVM versus BiLSTM with Explainable Prototype. So the motivation behind this project comes from a simple but very urgent reality. Misinformation spreads online faster than human can fact check. Every day we see fake articles, manipulated stories, and misleading content circulating on social media and news platforms. Human moderators simply cannot keep pace. This challenge led me to ask, can machine learning help? Not just in detecting fake news, but also in doing so in a way that is accurate, transparent, and trustworthy. This is the core of the project. It's not only about building a classifier, it's about ensuring that when the system says something fake, we also know why it came to that conclusion, and we can trust the probability it provides. Secondly, I have the aim and objective of the project. So the goal of the project is to create a trustworthy fake news detector that goes beyond simple binary classification. Instead, it generates calibrated probabilities to assist moderator in making nuanced decisions. To achieve this, I set out the following objective. To compare two major approaches, a traditional NLP method using TF-IDF with a linear SVM, and a deep learning approach using BiLSTM, ensuring that the model are not only accurate but also interpretable, so we can explain the prediction to stakeholders. Develop a prototype application that demonstrates real-world usability. This prototype should also allow users to paste articles, upload files, adjust threshold, and even retrain model within the interface. Finally, I wanted the entire workflow to be robust and reproducible, supported by consistent split, pinned requirement, and saved artifacts. So in short, the aim was not only to build detector, but to build one that people can trust, understand, and actually use. Third, I have the rationale of the project. So let me explain the rationale behind the method. First, I used TF-IDF with linear SVM as a baseline. This is a tried and tested method in text classification. It is fast, computational efficient, and competitive in accuracy. Most importantly, it is interpretable. With SVM, we can examine feature weight and understand which words push prediction towards fake or real. However, there are limitations in this method. Raw SVM score are not probabilities that make it different for moderators to know how confident the model really is. To fix this, I applied Platt scaling through the technique called Calibrated Classifier CV, which converts the SVM output into well-calibrated probabilities. On the other side, I introduced BiLSTM, a deep learning model. The rationale was simple. Deep model like LSTM are capable of capturing sequence information, meaning they don't just look at word counts, but also how word appears in context. The question was, would this outperform classical approach in fake news detection? Finally, explainability was essential. The system must allow stakeholders to see which words or features influence the prediction. Without this, the model is a black box and people are less likely to trust it. Nextly, I have the literature review of this project. So in literature review, I have the initial system functioned as a bag of words or TF-IDF using linear model, SVM logistic regression, and also tested character in n-gram. Deep models like CNN, RNN, and LSTM are capable of identifying both local and long-range text pattern, and they seem to exhibit better transferability. However, they require larger compute and careful calibration. Calibration becomes important with features for a level of explainability and level of safety. With safety critical applications, that is feature weight and attribution. Very important area of this of failure are data set biased based, relying on headline and domain shift. Nextly, I have the methodology of the project. So let me walk you through the methodology. This why is it art of the project. So in step 1, there is data and EDA. I use the Kaggle fake news dataset after cleaning and removing duplicates. I had about 38,600 roughly. Roughly 21,000 were real and 17,000 were fake. I worked only with the article text and labels. Titles, dates, and metadata were excluded to avoid bias. During exploratory analysis, I checked class balance, article length, and various cleanliness indicators such as URLs, percentage of uppercase text, numbers, and exclamation marks. For the step 2, I have done pre-processing. The pipeline includes regex, normalization, tokenization, limitization, and stop word removal. For the TF-IDF model, I use duplicated tokens, while for BiLSTM, I preserve term frequency. For the step 3, I have done split and vectorization. I used a single 80 by 20 split constant across all models. For TF-IDF, I considered word and gram for size 1 to 2 with sublinear terms frequency, min document frequency of 5 max. For the next 4th step, I have done the modeling process, in which I have used linear SVM, calibrated SVM, and BiLSTM. For the calibrated SVM, I have used linear SVM wrapped with calibrated classifier CV. For the BiLSTM, I have done embedding dimension 100, LSTM units 150, global max spooling, dense layer with ReLU and softmax output. Training included early stopping and class weights. The next step is evaluation. I evaluated using accuracy, macro F1, RAC AUC, and PR AUC. And also Breeze score for calibration. I also ran 5-fold cross-validation, generated bootstrap confidence intervals, and applied McNemar's test to check statistical significance of difference between model. For the 6th step, the prototype, finally I developed a Streamlit prototype app. The app allows user to paste a single article, upload CVs for batch analysis, adjust classification threshold, and view explanations of which term influence predictions. Users can also retain or switch between models within the app. The methodology pipeline ensured both rigor and practical usability. Nextly, I have the research outcomes and decision. Now, these are the results I came across from the EDA. And so in these charts, I can show that calibrated SVM, TF-IDF plus linear SVC achieved accuracy of 99%, macro F1 of 94%, ROC AUC of 0.9%, and the optimal threshold was about 0.55. Nextly, I want to go on the ethical consideration. Now let me highlight the critical aspects. Bias and generalization. The dataset may contain topic or publisher bias, so results should be assumed universal. Risk of minuses. Risk of probability are not guaranteed. The prototype clearly states disclaimers so users understand it. It is a triage tool and not absolute truth machine. So for the fairness, prediction applies to articles, not to individuals. The system does not label people, only text. This frameworks ensure that the system is not only technical, sound, but also ethically responsible. Nextly, I have the conclusion of the project. So before we go to conclusion, I would like to show you the prototype I have built. So this is the prototype I have built for the text classifier. For these we can use, so let's use so here's a text box and we can input the text here. So we can analyze the text if it's real or fake. So the result shows it's 38.4% real and 61.6% real. So these are the two data set I have been using, the true data set and the fake one. So if we take the text from the true data set, and analyze it. So the real data set shows that it is 89.3% real and 10.7% fake. So this is the threshold we can set for this. So if we take this data set, and we set the threshold to, let's say, max, it shows that it is 95.9% real and 4.1% fake. So I have also, this is the main objective of my prototype, but I have also added a few future like functions we can add to this. So here's a download template CSV. So if we click on download, there will it's gonna download a template in which so basically what this shows is a downloaded CSV. So yeah, so we can add text from different sources, like we can take a few sources we can find on social media or the internet, and we can add everything in here, and we can upload the CSV in here. So what that does is we can create our own data set and we can train it in our model which was trained in here. I have also added this section in which we can also choose in between few different model I have trained in my notebook. The prediction is mostly done through SVM in this, but we the optional model shows we can train from different models that I have trained in my project. So for conclusion, So for conclusion, a calibrated TF IDF plus linear SVM delivers strong performance and will calibrated probability surpassing a BiLSTM baseline on the dataset. The prototype provides actionable results, acceptable topic test, threshold control, batch analysis, and automatically with selected thresholding, explanations, and optional retraining. Future work includes evaluation on out-of-domain news, adding transformer baseline applied to calibration procedure, example Distilbert, multilingual support, adversarial robustness, and generating assemble word plus char features. So by saying this much, I would like to conclude my presentation. Thank you.